All right, here's what we got. Okay, so that's you standing on top of the blue building. And across the way is this ugly brown building. And we want to talk a little bit about some geometry. And we're going to introduce a couple terms. The two terms we're going to introduce are angle of elevation and angle of depression. So, first things first, I need to generate a horizontal. What does that mean? From my eyes, I'm going to draw a horizontal segment straight across. Okay? That's what's called the horizontal. Now, why is that important? Well, a couple reasons. Number one, it's going to be perpendicular here. Because the building is vertical, the horizontal is horizontal, and when a vertical meets a horizontal, it is perpendicular. Beautiful. Okay, so I marked 2 points. I marked point A and I marked point B. So we'll start with point A. If I look from the horizontal upwards, I get a path that looks something like this. Okay? And let me reemphasize, from the horizontal upward, so this angle. Okay? That angle is called the angle of elevation. Or the AOE. Again, from horizontal upward. And you're all fairly bright individuals, so I'm assuming that you would figure out that if I then go from the horizontal downward, I would get what's called the angle of depression. Or the AOD. Okay, that would be this angle. They're different in this case. Okay? Sometimes they'll be the same, sometimes they're different, but that's what they are by definition. So no matter how you set up the problem, you have to start by generating a horizontal. And sometimes that horizontal will be the ground, like this puppy down here is already horizontal, or other times, like this guy up here, you're going to have to generate that horizontal to figure out what the angles are. Okay, does that make sense? Yes or no? We're good? Okay, so how do we apply this? Well, I've got this handy-dandy little problem. In this problem, you are up in a hot air balloon, and on the ground is a dog. Yes, that's a dog. Give me a break. We know that the angle of depression from you to the dog is 55 degrees. So, AOD from you to the dog equals 55 degrees. We also know, for some strange reason, that the dog is standing 100 yards away from this point below the balloon. How high are you in the balloon? Everybody understand the problem? Yes? Good. The only thing we're missing is where is this angle? Okay, so we go back to what we talked about on the last slide, and that is from my eyes, I have to generate a horizontal going across. Now, a common mistake that people make when we get into angle of elevation and angle of depression is they think, well, first of all, that's going to be a 90-degree angle. You all see that. We can assume that you're measuring a distance perpendicular. But let me put this distance that we're looking in here. If I connect my sight from, connect the line from me to the dog, okay, the biggest mistake that people make is they think that that's a 55-degree angle. And it's not. Why is it not? Because the rules for angle of depression and angle of elevation is it has to come from the horizontal. That's why I started with a horizontal. Okay, so we want to get rid of that. Whoops. Put that back in there. Okay. And we want to figure out where to put the 55 degrees. Well, the 55 degrees, like I said, will be from the horizontal downward. So this will be 55 degrees. Now, that creates a little bit of a problem because you'll see that at the bottom here, this big puppy here is the right triangle we'd like to work with. The problem is I don't have any angles in that triangle. So help me. Other than the 90-degree angle, how can I figure out alpha or beta? Going back to the Greek letters, by the way, alpha looks like a fishy, beta looks like a bee with a tail. Any way to figure out alpha or beta?
Subtract 55 from 90 to get alpha.
Nora, that's an excellent answer, but I'm going to put you on hold for a second because you know what this means, kids. Tardy excuse bingo. Get your cards out. Jane.
Yes.
Why are you late?
Sorry, I thought the class started at 11:15, so I was looking at the old calendar.
Oh, hold on a second. I think that's one of our excuses. Number 4, everybody. Cross off number 4. Any winners yet? No? Okay. Going back to the problem. Nora, I was so excited about playing Tardy Excuse Bingo, I completely forgot what you said. Could you repeat it, please?
Yeah, I said subtract 55 from 90 degrees to get alpha.
Perfect. So that would make this 35 degrees. Okay, is everybody good with that? Excellent. How big is angle beta?
Degrees.
Why is he?
Because, well, those two angles have to equal 90.
Perfect.
So then you do 90 minus 35, and that's 55.
Perfect. Anybody have another reason why that angle is 55 degrees?
Because it's opposite to the other triangle.
Wait, who's talking?
Kira.
Kira, what'd you say? It's opposite the other, what do you mean?
To the other triangle, like they're even. Both triangles are adjacent, or congruent. Oops.
Okay. So you're saying if I do this, then I've got 2 triangles, and you're saying those 2 triangles are congruent, so if that's 55 degrees, that has to also be 55, which would make this 35. Perfect, that's 2. Can somebody come up with a third reason why that angle is 55 degrees?
The angles inside the triangle add up to 180, so 90 plus 35. And then if you subtract that from 180, you'll get 55.
I'll give you a half on that because that's kind of what I forget who was help. Was that Nora? Oh no, that was Izzy that gave me the. So 2.5. Can we get 3.5 out of that? I don't even know if I can do 3.5. 3.5. Horizontal up here. Horizontal down here. Therefore, what can you say about the dashed line in the ground?
They're parallel.
Outstanding. And if they're parallel, then what kind of angles are the 2 55-degree angles? Parallel lines, transversal. This is awkward. Come on. I got stuff to do. Give me an answer.
Is it skew?
Nope, those are segments. What pair of angles? We had 10 pairs of angles. Which ones are these guys? The 55s. I'll narrow your 10 choices down to 5. Corresponding same side interior, same side exterior, alternate interior, alternate exterior.
alternate exterior?
No, they're alternate interior. They're in between the parallel lines. Okay, so that's 3.5 ways that these two angles are congruent. So in order to solve for h, realize that this over here is also going to be h. So you have to choose which triangle do you want to work with. I didn't have to deal with any of this gunk about beta and alpha. I could have just worked with this triangle. Or, if you get sneaky, we could go back to what Nora said and get the 35-degree angle and work with that. Or we can do what Izzy said and use that as a 55-degree angle. It doesn't matter. So since Nora went first, let's use Nora's information. And we're going to work with this, get that out of there, this 35-degree angle to find h. Let's see. Aiden, what trig function am I going to use if we use the 35-degree angle, h, and 100 yards? Sine, cosine, or tangent?
Sine.
Strike one.
Cosine.
Strike two.
So it's tangent.
Tangent. There you go. By process of elimination, opposite side, opposite side, adjacent side is tangent. So the tangent of 35 degrees is equal to the opposite side over the adjacent side. Switcheroo. H is equal to 100 divided by the tangent of 35. Type that into your calculator and please tell me how tall you, or how far up in the balloon you are. I'll wait.
Around 142.8.
Whoops. 142.8 yards. Can somebody confirm that, please? Okay,
Yes.
good. We have confirmation. Well done. Is that answer reasonable? Yeah, it seems reasonable. Okay. That's pretty high up, but that's okay. Let's go back to what Izzy told us and make this angle the 55 degrees again. We'll get rid of Nora's angle because we don't want to get confused in there. Okay. So one thing you should notice, our angle of depression from us or you in the balloon down to the dog is the same as the angle of elevation from the dog up to you. And hopefully you followed why that's true. Again, the horizontal from your eyes and the ground are parallel. We get alternate interior angles. So you have a lot of different opportunities to solve this problem. Like I said, we chose to use the 35 degrees that Nora gave us. We could have used the 55 degrees from Izzy and solved the same problem. We could have worked with this triangle over here, or we could have worked with that triangle. We have a lot of different options. Hopefully by now you realize that this is one big rectangle. Okay? Questions? Beautiful. Let's make things more interesting, shall we? Let's figure out how to measure the height of something we can't measure the height of. In other words, in the balloon problem, I could conceivably drop a giant piece of string from the balloon down to the ground and measure that piece of string, and we're good to go. Okay? There's a lot of different ways I can measure that height, but we're going to measure the height of something we can't measure. Let's say, for instance, this is the peak of some mountain, and we want to know the height of the mountain. I can't dig down to the bottom of the mountain here and use a piece of string to measure the height of that mountain, so we have to come up with a different technique. This is commonly called a mountain problem because we're measuring something, and for some reason mountains are usually the example that we use. Okay, so we're going to use a simple technique. I need to measure 3 things, and that's it. I'm going to start at this point B. And from B, I'm going to measure the angle up to the top of the thing that we're trying to measure. Okay, so let's suppose that this is, I measure that, and you can measure angles a lot of different ways, but I measure it and I get 40 degrees. That's fairly doable. Then I back up. How far am I backing up? I'm going to back up 2 miles. So again, I'm assuming I got a long flat road in front of the mountain. I measure the angle, and then I back up 2 miles, and I remeasure the angle. Will angle A, Joey, be bigger or smaller than angle B?
Smaller?
Hot diggity. Well done. And in fact, I happen to know that it's 25 degrees. That's an important concept for everybody. As you back up, the angle gets smaller, or if you move forward, the angle gets bigger. That's fairly easy to check. I mean, you could, I look up at the corner of the room. As I step forward more, that angle is going to increase. As I back up, that angle gets lower and lower. And again, we're assuming, I should have started with that. We've got a 90-degree angle there. All right, Jessa, how many triangles are in this picture?
3.
Nice. Good. How many of those triangles, how many of those 3 triangles, Jessa, are right triangles?
2 of them.
Hot diggity. Oh, okay. Aiden was already here, so we don't get to play tardy excuse bingo. Aiden, what happened?
My Wi-Fi stopped working.
I understand.
Sitting in the connecting thing.
I understand. Where was I? Oh, triangles. So 2 of those triangles are right triangles. We can work with right triangles. We cannot work with non-right triangles. Okay, so this triangle here is no good. We're not going to go anywhere near that one. And that's something to keep in mind as we solve this problem. There are 2 components to this problem. One is the trigonometry. The other one is the algebra. For the most part, I find students do okay with the trigonometry. It's the algebra that could kill a donkey from 100 paces. So we're going to go very slow through the algebra. All right, here we go. Let's see. We'll get some color coding here. I think we'll use a pink. Whoa, that was wrong. Trying again. We want a right triangle, pink, good. So here's one triangle in pink. And then we'll do the other one in, let's say, green. Okay. All right, Philip, you're up. Philip W. Talking about the green triangle. Oh, wait, hold on. We need some labeling here. H, we want H to be the height of the thing we're measuring. And somewhere along the way, we're going to have to use this distance, which I'm just going to call X. You can call it whatever you want. I chose to call it X. We're going to need those things. Notice that neither one of those is physically measurable. I can't measure the height of the mountain by digging into the mountain, and I can't dig all the way to the center of the mountain. So those are just variables. All right, Philip, back to you. What trig equation would you get for the pink triangle?
To find what distance?
H and X. So let me rephrase my question. What trig equation could you set up for the pink triangle using H and X and the 40-degree angle?
I'm not sure.
From the 40-degree angle, is H hypotenuse, adjacent, or opposite?
Opposite.
Okay, and is the... Go ahead.
Cosine?
No.
Wait, tangent.
Tangent. Keep going. Tangent of 40 is equal to? H over X or X over H?
H over X.
Well done. Not a solvable problem. There's 2 variables, 1 equation. Can't solve it, so we need another one in green. Before we do that, how long is that, Marcus?
How long is which point?
The green.
I'm not sure.
You don't know how long this green bracket is? The bottom of this triangle?
Wait, no. Wouldn't that be 6 miles?
No?
Or no, 2 plus X.
Thank you. I'm going to write it as X plus 2 for no particular reason. Okay. Nico? You there?
Sorry, what was the question?
I didn't ask a question yet. I was just making sure you were there.
Oh.
What trig equation do you get now using the green triangle, the big one?
I'm not sure.
Lily, help me out.
Tangent 25.
That's a good start. Is equal to?
H over x plus 2.
Perfect. Well done. Okay, we're done with the geometry now. Therefore, we need to do some solving. I'm going to use this equation and this equation to solve it. And I'm going to need a lot of room, so I'm going to move to the next slide. Is everybody okay with this before I move on? Going once, going twice, sold. Okay, so our equations are the tangent of 40 is equal to h over x, and the tangent of 25 is equal to h over x plus 2. Okay, how to solve this? I'll show you how I do it. There's a lot of different ways to solve this. I'll show you how I do it. You can use whatever technique you want. Now, for those of you that are memorizers and you're just going to write down the way I solve this and try to apply it to every problem, it's not going to work. This is one possible mountain problem. There are many variations, which you'll see on the homework. So it's more important that you understand the method versus just memorizing the technique or copying down the technique. All right, so what I'm going to do is I'm going to start with this red equation over here, and I'm going to multiply both sides by x so that I have that in terms of h. I'm going to do the same thing with the other side. Rachel, I just made a crucial math mistake. Could you tell me what it is, please?
I think it has to do with the x plus 2.
You are correct. Could you be more specific?
I don't think you could have it like that. I think you need parentheses around it.
Well done. Good. Okay. Those parentheses are crucial because without the parentheses, the only thing I'm multiplying by the tangent of 25 is the 2. I need the parentheses. Okay, so you look, both equations are equal to h. Therefore, I can set the equations equal to each other. X times the tangent of 40 is equal to x plus 2 in parentheses times the tangent of 25. You'll also notice I'm not plugging in the tangent of 40 or the tangent of 25 into my calculator. I'm doing that at the very last step because we want to keep this answer as accurate as possible. Okay, x times the tangent of 40 is equal to x times the tangent of 25 plus 2 times the tangent of 25. Your friend and mine, Mr. Distributive Property. If it has an x, it goes to the left. If it doesn't, it stays on the right. X times the tangent of 40 minus x times the tangent of 25 is equal to 2 times the tangent of 25. How we doing so far? Give me a thumbs up if you're following me, please. Good. Okay, more algebra. These two terms have an x in common, so I'm going to factor out an x. By the way, another common mistake is when people get to this stage, they take the tangent of 40 minus the tangent of 25 and get the tangent of 15. That's bad math. Don't do it. Move this up a little bit. Last step to get x by itself. 2 times the tangent of 25 over the tangent of 40 minus the tangent of 25. Now, you could be saying to yourself, what is he doing? We don't want this. If we go back to the original problem, we're looking for h. Why is he solving for x? because that's how I chose to do it. You could have solved the equations for x and set them equal and then get h directly, but I think this is easier because all I need to do once I figure out what x is plug and chug to figure out what h is. Okay, I'm done. Now, pick up a calculator and do this so that you understand what you're doing. Type this into your calculator and see what you get for an answer. Be careful with parentheses. Let's see. When will we talk to? Lexi, what'd you get?
I got 0.65.
Can somebody confirm, please?
Yeah.
Yep, yep. Did anybody get 2.5?
I did.
Yeah,
Me too.
yeah. I got 2.5. So, but I know how you got 0.65, and I'm guessing it's a parentheses error. So let's talk about the parentheses on the calculator. Whether you want to or not, the calculator is going to put parentheses in there. If you don't handle the parentheses carefully, then it goes out of order and does the calculations wrong. So when I put it into my calculator, I put the whole numerator in parentheses. So notice I have a double parentheses after the 25 there, because one to close the tangent of 25, another one to close the numerator. Then I put the whole denominator in parentheses. Again, double parentheses on the right. Okay, so for those of you that got 0.65, that's okay. Do it again to make sure that you get, I have 2.50170439 dot, 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 dot. We want this answer to be as accurate as possible, so therefore I'm going to take that answer and I'm going to store it into x. So now whenever I type x into the calculator, it'll use the exact value there. Not just 2.5, but it'll do 2.50170439 blah, 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 whatever it goes on with. Questions so far? Okay, still haven't found h. How do we find h? We take this number right here and we bring it back up to this guy. Whoa, my bad. This guy. And so on my calculator, since I stored that big hairy number into x, I can just do x times the tangent of 40, and I get h being 2.1 miles. 2.0999 whatever, which rounds to 2.1 miles. Okay? The last thing I'm going to do is ask myself, is that a reasonable answer? If I go back to the original problem, if this is 2 miles and these are like 40 and 25, is it reasonable for a mountain to be 2.1 miles high? Probably. Is it reasonable for us to be 142 yards up in the air in a hot air balloon? Yes. If you solve this and you get something like 347, you probably did something wrong. You're not going to get a mountain that's 300 miles tall. So there is a little bit of real world involved in this. Okay. Any questions on this approach? We're good? Okay, so again, 2 components to this. One is how to set up the geometry, which is what we did on the first slide. Getting this equation and getting this equation from this picture. And again, the equations will change depending on the given information. For instance, I might give you the height of the thing we're measuring and have you calculate how far you backed up. I might give you the height and have you calculate how far you are away from the bottom of this thing. So find h, find x, find the distance, etc., etc. So understanding how to set it up is more important. That's part one. Part two is the algebra in solving that equation. Remember not to put the tangent values into your calculator until the very end. I want to see this final value before you type it into your calculator. There's a lot of little spots here to make mistakes. Distributing, making the mistake I talked about over here, that is not the tangent of 15, etc., etc. Okay? And then lastly, does the answer make sense?